Our number system is comprised of natural numbers, which are the counting numbers, whole numbers, integers, rational and irrational numbers, real numbers, and imaginary numbers, and finally complex numbers, which is a combination of real numbers and imaginary numbers. If you're not familiar with imaginary numbers, I've linked a video at the end of this one defining the number I. I'll just do a brief review of it. The imaginary number I is defined as the square root of -1. And if you think about it, -1 times -1 is the number 1. And 1 times 1 is also 1. And when we're squaring a number, it has to be the same number times the same number. So I can't have 1 times -1 because they're not the same number. These are two distinct numbers separated by two spaces on a number line. So in order to have this exist, we just simply call it I. So if I had a definition would be 5 times I is 5 times the square root of -1. In the following four numbers, square root of -7 can't be simplified any further, so we just say square root of 7. The square root of 4/9 is 2/3, because 2 times 2 is 4, and 3 times 3 is 9. And then this one over here, this is the same as the square root of -1 times the square root of 4. And we can simplify the square root of 4 to be a 2. And the square root of -1, we can simplify that by saying it's 2i. And then this one over here, I'm showing it just as an example. This minus sign is not under the radicals, so this is not able to be simplified any further. It's the square root of 5, minus square root of 5. Here we have two quadratic equations, and I want to solve them, so they're set equal to 0. So in the first one, what I want to do is I want to subtract 4 from both sides. And then to find the value of x, I have to take the square root of both sides. This can further be simplified by being the square root of 4 times the square root of -1. And the square root of 4 is 2, and the square root of -1 is I. So our final answer is 2i. Similarly, to solve this one, I subtract 9 from both sides. And then taking the square root of both sides gives me that x is the square root of -9, which further simplifies to be the square root of 9 times the square root of -1. Square root of 9 is 3, and the square root of -1 is I. And this one's complete. The next step in learning how to do this is we find the equality of two complex numbers. So here we see that I have a real number, a real part here and here, and then I have an imaginary part here and here, and they're mixed inside the same equation. The first thing that I want to do is I want to group together the real numbers, which are 2x and 10, and I'll set those equal to each other. And then the next part is I want to set the imaginary components equal to each other, giving us -7i equals yi. And then what I'm going to do is I'm going to solve both of these. Well, 2x equals 10. If I divide both sides by 2, I get x equals 5. And then for -7i equals yi, in order to do this, what I would do is I would divide both sides by I, and this would give me -7 equals y. So with this next example, why don't you try to do this in your notebook? You can pause the video now. We start by first grouping the real number components, and I see here that I have 9 and 2x, so I'm going to put, if I divide both sides by -2, I get that x equals -4.5. Grouping the imaginary components together, I get 4yi equals 3i. In order to solve this, I'll divide both sides by I, which then gives me that 4y equals 3. Dividing both sides by 4 I get y equals 3/4. Taking the information that we just learned from that last exercise, I can see that if I'm going to add or subtract complex numbers, we'll look at adding first. Adding complex numbers, I first group together the real components A and C, and then I add to that the B plus the D, pulling out the I. And that goes on the end here. So let's try an actual example of adding with complex numbers. So here in this example, we're going to take the real numbers and group them together, and we'll group the imaginary numbers separately. So once I do that, I have 8 plus 7 plus minus I plus 4i. So on the left, the 8 plus 7 becomes 15, and the minus I plus 4i becomes 3i. So our final answer is going to be 15 plus 3i. Now let's look at subtracting complex numbers. It should be pretty intuitive. So when I'm subtracting these, I'm going to group together the A and the C, and since I'm subtracting, it's A minus C over here. And then I'm adding to that B minus D, and the I is outside. So let's try an example. So now we're subtracting, so we're going to group together the 10 minus 3 plus, then we have minus 6i minus 6i. So minus 6i, I'll write it this way, minus 6i. And when I subtract a negative, I'm adding it. When I do 10 minus 3, I get 7. And then when I have minus 6i plus 6i, that's 0. So the answer is just going to be 7. This practice question actually is a combination. You'll see that it's a subtraction problem, but at the same time I have a plus 4i over here. So what I want to do is I want to kind of look at this as if it was two different problems. So over here, there's a real component here, but there's no imaginary component on this side, but it works the same way. So I would group together the real numbers. So I have 14 minus 2. And then just for illustration, you don't have to do it this way, but just to explain what's going on here, because it's going to confuse that this sign is going to become a minus, and it's because of this one. So I have 14 minus 2, those are the real numbers. And then I'm grouping together over here, let's say that there was a 0i here. So I have 0i minus 7i. So rewriting this, I would get 14 minus 2 is 12. And then in here, I'm just going to have the minus. So when I add a negative number, this becomes minus 7i plus 4i. And now inside, I have, actually don't need the parentheses anymore. So then I have 12 minus, and I have minus 7 plus 4 is minus 3i. And that's the final answer.